how exactly rotation, revolution happens, then how tiltation affects, what is solstice, what is equinox, how length of day and night is affected by revolution and tiltation of earth, what happens in summer, what happens in winter, how the change happens from solstice to equinox, what happens at the poles, what is polar day, polar night. I hope everything is clear now. Hello everyone. Today we are going to understand about the different motions of earth, that is rotation and revolution. We'll also understand how seasons are formed, what is solstice, what is equinox. So first, in rotation, rotation is the movement of earth on its own axis. So if this is the earth, then what is the axis? Axis is an imaginary line that makes an angle of 66.5 degree with the orbital plane. Orbital plane is the plane that is formed by the orbit. Earth goes around in an elliptical orbit. So if this is the orbital plane, then this angle 66.5 degree is the angle which the axis makes. Okay. And the movement of the earth around this axis is called rotation. Now rotation of earth, what does it cause? It causes day and night. Now let's come to revolution. Revolution is the movement of the earth around the sun. If this is the sun, then the earth moves around in an orbit. This is revolution. Now revolution causes seasons. We'll see how. And it also causes the change in the length of day and night. So day and night is caused by rotation, but the length of day and night is determined by revolution. There is one more factor that affects seasons and the change in length of day and night, which is tiltation of the earth, which I mentioned that the axis of the earth makes an angle of 66.5 degree with the orbital plane, or we can say that with this line it makes an angle. Okay, so let us now see that how exactly this tiltation of earth affects the amount of sunlight that earth receives. So let's say if the earth was not tilted, if it was straight like this, so this is the equator, Tropic of Cancer, Tropic of Capricorn, and this is the real earth which is tilted, equator, Tropic of Cancer, Tropic of Capricorn. And let's say that this is the sun. Okay, just don't pay attention to the drawing. This is the sun. So here you can see, if the earth was not tilted, then all the rays would be directly overhead and every part would receive equal amount of sunlight. But because the earth is tilted, here the Tropic of Capricorn receives more sunlight than the Tropic of Cancer, because the southern hemisphere is closer to the sun here, as you can see. So this is why different amounts of sunlight is received by different parts of the earth due to the tiltation. Now let us see the formation of seasons. See, seasons are formed due to two reasons. One is the revolution of earth, another is the tiltation of earth. Let us see how. There is a term, solstice. Solstice means it is either of the two times of the year when the sun reaches its highest or lowest point in the sky at midday, marked by the longest and shortest days. Okay, let me simplify it. First, if we talk about June solstice, then if this is the sun, this is the earth, this is equator, Tropic of Cancer, Tropic of Capricorn. So when the northern hemisphere is facing the sun and the rays are overhead, like directly falling on the Tropic of Cancer, that is called June solstice, and that happens on 21st of June. This is also the day when the length of the day is the longest and the night is the shortest. Okay, so June solstice, northern hemisphere is tilted towards the sun, rays are overhead at Tropic of Cancer, summer is in the northern hemisphere, and places beyond the Arctic Circle, you see the places beyond the Arctic Circle here, they continuously receive sunlight, so it is called polar day, like it receives continuous daylight for 6 months. And in the southern hemisphere there is winter. Now let's talk about December solstice. Again, it is the time of the year when the rays are directly overhead, now on the Tropic of Capricorn, and the southern hemisphere is tilted towards the sun. Rays are overhead at the Tropic of Capricorn. Summer is in the southern hemisphere, and places beyond the Antarctic Circle, they receive continuous daylight for 6 months. And there is winter season in northern hemisphere. So these two solstices are very important. It happens on 22nd December, the winter solstice. See, this is summer solstice and this is winter solstice. Here summer is in the northern hemisphere, okay? We are talking with respect to the northern hemisphere. So whenever I say it is summer, then you assume that I am talking about northern hemisphere. We can also say that this Antarctic Circle, places beyond Antarctic Circle, during summer solstice, it is night there, right? It does not receive any sunlight for 6 months. Now let me explain this in a better way. Okay, see, equinox is the time of March 21 or September 23. It is the transition between seasons, like this is autumn, this is spring, again in the northern hemisphere, and this is autumn. So we can say that on 21st March the sun rises and the 6 months of daylight begins. See, this is the sun. Now this is the equinox position, okay? Now here the sun rays are not overhead on any one of the Tropic of Capricorn or Tropic of Cancer. It is overhead, like it falls equally on all parts of the earth which is facing the sun, okay? That is what we call as equinox. And this is the 23rd September equinox. This is the 21st March equinox or the spring season. In 21st March, the sun rises and the 6 months of daylight begins. Then it revolves around the sun and this position comes. Now you know what this position is. This is the summer solstice. Summer in the northern hemisphere. And here the rays are overhead directly on the Tropic of Cancer. Then it again revolves and it comes here 23rd September. Again all the rays are falling equally on the earth. Now here again it revolves and this is Tropic of Capricorn and this is the winter solstice. Now you understand. Again it revolves and goes to 21st March equinox. Now let me explain to you an important aspect. You understood what is equinox, what is solstice, how seasons are formed. Here it is the summer season. Why? In the northern hemisphere, because the rays are falling directly on the northern hemisphere. Specifically during summer solstice, it is falling on the Tropic of Cancer. Then it revolves, and this is the autumn season. Change of season is happening, and all the rays are falling equally on the earth's surface. And then it again revolves, and now it's winter solstice. It's winter in the northern hemisphere because the rays are falling directly on the Tropic of Capricorn. Again it revolves, and now it is the spring season. Okay? Now let me explain an important thing, that is length of day and night. See, again the length of day and night is caused by the tilt of Earth's axis and revolution of the Earth. Now what does the tilt of Earth's axis do? Due to the tilt, I explained that one hemisphere gets more sunlight than the other hemisphere, okay, at different times of the year. And due to the revolution, the angle at which sunlight hits each part of the earth, it changes. Like I told you, during the summer solstice, the sunlight hits directly the Tropic of Cancer, but during the equinox, due to the revolution, this position of earth changed, and that is why the amount of rays received, that also changed. Now it is not direct over the Tropic of Cancer, it is falling equally on all the surfaces of earth that is facing the sun. Again in winter solstice, the rays will be overhead on the Tropic of Capricorn. You understood why these two factors, tilt and revolution, how these affect the amount of sunlight that is being received. So now if we talk about summer in the northern hemisphere, we'll say that the northern hemisphere is tilted towards the sun. Okay, the sun rises earlier and sets later. Why? Because here most part of the earth of the northern hemisphere, it is facing the sun directly. Okay, like if you try to imagine the places beyond the Arctic Circle, they receive direct rays and they have day of 6 months. Okay, we can say that the longest day here is on which day? 21st June, or the summer solstice. There is one more thing, variation by latitude. See, the equator, the day is around 12.5 hours. Then at the Tropic of Cancer, the day is around 14 hours. Okay, I'm telling you the difference between the day and night. This is day, 14 hours day, 12.5 hours day. Then in the high latitudes like in UK, the day is around 16 to 18 hours. Then Arctic Circle, the day is of 24 hours. Now you see that on equinox, 21st March, the sun has risen, and on the Arctic Circle there is a day of 24 hours, and this is going to be there for 6 months, right, until this equinox again, right? So here what happens, as it moves from 21st March to 21st June, there will be continuous daylight, and it is called polar day, and this continuous daylight would keep getting brighter. Okay, this part, the Arctic Circle will have the brightest day, and after that the brightness will reduce, and here it is going to set, the sun is going to set. Now at this point the polar night starts. Here it was polar day, it started and it stayed till this, and then polar night starts, that will stay till here, and then it will go. Now you understand how the poles are getting affected due to the tiltation and the revolution of Earth. I hope you understand, and keep in mind that there is one thing that is important, that is the variation by latitude, which says that as we move from the equator towards the poles, the difference between the length and day, it changes. Like I showed you here, when it was summer in the northern hemisphere, the equator has 12.5 hours day, Tropic of Cancer has 14 hours day. So you see that the length of day is increasing until Arctic Circle, where it is complete daylight for 6 months. Okay, and again if we say about winters, the situation will get reversed. Winters in northern hemisphere, variation by latitude. Can you guess what is going to happen here? The equator will receive around 12 hours daylight. The Tropic of Capricorn will receive around 10 hours daylight. Now it is decreasing. Earlier it was increasing in the northern hemisphere. Sorry, Tropic of Cancer, not Capricorn. Earlier at this position, summer solstice, with the latitudes, the length of day was increasing. Now at winter solstice, with the latitudes, along the latitudes, the length of day is decreasing. Why? Because here it is night, it is continuous night, and here it is continuous day. So here it will increase, the length of day will increase in the southern hemisphere during winter solstice, and the length of day will decrease in the northern hemisphere during winter solstice. I hope you understood. Arctic Circle, it will be 24-hour night or 0 hours day. Okay, this is polar night. So you understood? Let me just summarize. This is the sun. We see this diagram very often, but I hope you understood this today properly. See, this is the summer solstice. Okay, wait, just 21st March. Let us start from here. Summer solstice, 21st March. The rays are overhead on the Tropic of Cancer, and Arctic Circle has daylight continuously for 24 hours. Okay, and across the latitudes, the length of day is increasing. At the equator it is around 12.5 hours, then it is around 16 hours, then here it is 24 hours. Now the earth is revolving, it comes at this position. This was summer solstice, this is equinox, 23rd September. Now here what is the case? The rays are overhead, not on any particular latitude, it is evenly distributed. And here now it is the autumn season in northern hemisphere, and in the poles what is happening? the sun has set. The sun has set, and now the polar night is beginning here. Polar night begins. Okay. Now again the earth is revolving, and at this position it is 21st December, again solstice. Now what is happening at the pole? It is still night, it is away, and this is day. Okay. The rays are overhead on the Tropic of Capricorn. Here it was overhead on Tropic of Cancer. Now it is overhead on Tropic of Capricorn. And now you see, if we go towards the North Pole, the length of day is decreasing. Why? Because it is night here in the Arctic Circle, and on the equator it is day. It is day of around 12 hours, and then it is decreasing. It becomes 10 hours as you move towards the pole, North Pole. Then again the earth revolves and comes at this position. What is this? This is 21st March equinox. At the equinox there is some change going on in the poles. See, again the rays, they are falling evenly on the earth's surface, and in the Arctic Circle now the sun is rising. Till here it was day, right? It was night at the Arctic Circle. Now the sun is rising and it is daylight. In polar day is beginning here, you can say. Polar day begins. Again the earth revolves and it comes here. Here the day gets brighter at the Arctic Circle, and the sun is at the highest position in the sky. Okay, so this was all. I hope you understood how exactly rotation, revolution happens, then how tiltation affects, what is solstice, what is equinox, how length of day and night is affected by revolution and tiltation of earth, what happens in summer, what happens in winter, how the change happens from solstice to equinox, what happens at the poles, what is polar day, polar night. I hope everything is clear now. Thank you for watching.